Arizona Science is supported by Research Corporation for Science Advancement.
For ACPM, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Bryan Black, an Associate Professor in the University of Arizona's Laboratory for Tree Ring Research, who has been leading a team that pinned down the date of an earthquake 11 centuries ago that could have important consequences for the Pacific Northwest. Welcome, Bryan.
Thank you.
Could you tell us first a little bit about the story of the earthquake that you've been studying?
Yes, the Puget Sound region is underlain by several shallow faults, and several of those are under major metropolitan areas like Seattle, Tacoma, and Olympia, and so have been a concern about their recurrence because they rupture very infrequently. So we need to have records that go much farther back in time than observational records to determine how frequent and what size those earthquakes were.
And so there was a particular earthquake or earthquakes that you were trying to go after?
Yes, geologists had noticed several features on the landscape of landslides, evidence of a past tsunami in Puget Sound, and major landslides in Lake Washington and Lake Sammamish and the major metropolitan area of Seattle. And all these dated to about 1,100 years ago.
Bryan, you studied tree rings. How can you use that to date earthquakes?
Well, earthquake activity can kill trees. And so in this major earthquake, we had trees that were part of major landslides that slid off of mountains into Lake Washington and Lake Sammamish, or other trees were drowned when faults ruptured and thrust up a cliff that impounded a stream that then flooded a forest and created a lake. And we can go back to that lake and still find those stumps that were drowned all those years ago and sample them. And if we can determine when the trees died, we know when the earthquake occurred.
I think most of us are aware that trees add a ring each year so you can count them, but on a tree that died more than a millennium ago, how do you know what year to start counting?
So as climate varies over time, it induces synchronous growth patterns in trees, time-specific barcodes in their growth. And what we do is match those time-specific barcodes among trees, first of all, that were killed during the earthquake, and then we're fortunate to develop a very long 1,300-year chronology from living trees that we could match those earthquake-killed trees against. And when we got the match, we could determine when the earthquake-killed trees lived and then when they died.
So now you know that all of this seismic activity occurred in a single half year. What are the implications for Seattle and the Puget Sound region?
Well, what we found is that there are two faults involved, one of which is the Seattle fault that runs right under Seattle, and another in the Olympic Mountain foothills, called the Saddle Mountain Fault. And they're adjacent to one another, and it turns out that they ruptured at about the very same time. It was a two-fault earthquake event. And so within that 6-month period, either those two faults ruptured in rapid sequence within hours to days or months of one another, analogous to what happened near Turkey and Syria back in February with those terrible linked earthquakes that occurred there, or that those two faults could have linked together and ruptured in one single earthquake with their energies combined into a much larger earthquake than either fault could have provided alone. But what we showed is that these multiple faults can link together to generate different hazards than if they had ruptured individually over, say, a 100-year period. Instead, we show that they can rupture together and within a 6-month period over hours to even months.
Does that have implications for disaster preparedness for Seattle?
Yes. Right now, current hazard planning does not include the possibility of linked faulting. And so our work shows that linked faulting is a possibility.
I'm a little curious about the logistics of this problem. You had to cut down dead trees that were underwater. Are trees that are underwater preserved well enough to study the rings?
Yes, we were fortunate that these trees were preserved in cold, low-oxygen environments, but was still a very considerable challenge to sample them because we had to get divers and an underwater chainsaw that's driven by hydraulics to the site and then sample these trees underwater. So there was very low visibility and difficult working environments, but we were fortunate that the U.S. Geological Survey had extremely skilled divers who were able to harvest these samples that we needed to finish the project.
Sounds good. Thanks for talking with us, Bryan.
Thank you.
Our guest today has been Bryan Black, an expert on tree rings who has been applying that expertise to study the seismic history of the Puget Sound region. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.